Hello and welcome back to day 8 of 30 minutes of problem solving a day. And today what we're going to be doing is, because we've done math and we've done CS, now we're going to do FMA, okay? And if you guys want me to do more math and CS, please let me know in the comments and I'll go back to that. But for now, I'm just doing whatever the heck comes to mind first. So FMA is what comes to mind, let's do it. I know that I said that I'm probably not going to do much more FMA, but I think FMA is fun. Let's just solve some physics problems. I've not solved physics problems in so long. Holy moly, dude. But before we get into the video, remember to like and subscribe, okay? It helps me out a ton. Remember, you could donate too, okay? That's helpful too. Remember that if you're interested in participating in Carrara courseware, that you could join in the form using the form in the description. Very nice, we made it. And what else do I want to plug? Oh yeah, another thing is I do daily CS patas on my Discord server, so if you guys are interested in that kind of thing, go check it out. It'll be very epic. But other than that, let's just get into it, okay? Enough trolling around. We'll put a 30-minute timer for now, and we'll get started. Okay. So, number 1, consider a dripping faucet. Okay, maybe I should open. Okay, I'll do like 5 at a time and then check my answers. So let me duplicate and go back. And where was it? 2012. Okay. Don't look at the solutions yet. Okay. Consider a dripping faucet where the faucet is 10 centimeters above the sink. The time between drops is such that when one drop hits the sink, one is in the air and another is about to drop. Okay. At what time above the sink will the drop be in the air, right? Okay. So, I don't know why. Hold on, there we go. Okay. So, essentially it's saying that we have drop, 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 right? And it should be something like this, actually, right? Because essentially your distance you drop is like 1/2 gt squared, right? So, essentially, t should be such that, like, 2t, or this height, like, h is equal to 2t squared, right? Where t is the difference. So, essentially we get 2gt squared is equal to h, where t is the amount of time between the droplets, right? And essentially we want to find out what 1/2 gt squared is. So, I mean, 1/2 gt squared is going to be h over 4, so our answer should be 10 over 4, which is, I mean, we could literally just because it's half the amount of time. So 10 over 4 is, why did it take me so long? 5 over 2 equals 2.5, there we go. So it should be a B, very nice. 1B. 2. A cannonball is launched with initial velocity of magnitude v0 over a horizontal surface. At what minimum angle theta min above the horizontal should the cannonball be launched so that it rises to a height h, which is larger than the horizontal distance r that it will travel when it returns to the ground? I'm pretty sure for 45. Wait, no, what? Actually, I guess that is slightly off. Okay, so let's just do it out, right? So the height you go is like v0y squared is equal to 2gh, right? This is just a conservation of like vertical velocity kind of thing. So, is that right? Yeah, that's right. So essentially we have v0 theta min squared, or no, sine theta min, right? v0 squared sine theta min squared is equal to 2gh. Okay. And then we basically have that our horizontal velocity is equal to the time times v0 cosine theta min, right? So I guess this is just like root 2gh, right? Then we need to find the time it takes. So that shouldn't be that hard. Well, yeah, basically you have v0y, because it goes to a horizontal surface, right? So it starts at v0y and then it ends at negative v0y, right? So v0y minus 2g, or minus gt, is equal to negative v0y, which is why your t is just equal to 2 v0y over g, which gives you that v0 squared sine theta min over g, 2 of this over g, is equal to our horizontal distance r, right? So this is r, and this is capital H. So essentially we have v0 cosine theta min over, wait, what? Let's see. So we can substitute this in here, right? Okay, let's just solve for g, right? Or h. So h is equal to v0 squared sine squared theta min over 2 g, right? So to get from h to r, we basically had to multiply by 4 and divide by sine theta min and multiply by cosine theta min. Alright. Oh, so that actually gives us something nice, right? So height times that gives us r, right? So essentially we just need tan theta min to be so it's over, yeah, it's over tan theta min. So tan theta min has to be greater than 4. So let's just see what's tan inverse arctan of 4 times 180 over pi is 76. Okay, so it should just be A. Again, let's go. No, just kidding. 1 with B. I'm trolling. So 2A. Very nice. Very nice. We got it, boys. We are not that bad at F1. We can solve problems 1 and 2. I'm so proud of myself. Okay. An equilateral triangle is sitting on an inclined plane. Friction is too high for it to slide under any circumstances, but if the plane is sloped enough, it can topple down the hill. What is the angular? Oh, okay. So this is kind of a troll problem. It's basically like, what point is the center of mass, like directly above this boy, right? And then we know that this does a 30-degree angle. So we need this to be a 60-degree angle, right? So that this is a 90-degree angle, and any more, it'll be to the left, so it'll actually pull it down. So our answer is C, 3C. A particle at rest explodes into 3 particles of equal mass in absence of external forces. The 2 particles emerge at a right angle with equal speed v, and then this guy goes up the way at v root 2. Very nice. So B. Am I trolling? Hopefully I'm not trolling. Pretty sure that's right. 4B. 5. A 12-kilogram block moving east at 4 meters per second collides head-on with a 6-kilogram block moving west at 2 meters per second. 6. Dang, this guy has so much momentum. What the heck? That's crazy. Alright, so essentially we got 12 this way, 48 that way. Okay, so I guess they go 36 over 18. So essentially they go 2 meters per second left, right? Together. So you basically have 18 times 2 squared, 1/2 that. That's your new kinetic energy. And then your old kinetic energy is equal to 1/2 times 6 times 4 plus 1/2 times 12 times 16. And we want to simplify this, so we could get rid of the halves, it doesn't really matter. Divide out of 4. Could we divide out a 6? Yeah, we could in fact divide out a 6, or 8, sorry. So you get 9 is equal to 3 plus, divide out the 8, right? So it'd be plus 24. Or, no, you want to subtract minus 9 over here. And then we got to make sure to multiply the 8 back, and then divide by 2. Okay. Do not forget to do that. So essentially we get 27 minus 9, 18 times over 2. 18 times 4, 72. Alright, D, 5D. So we said we were going to do 5 and then check our answers. Let's check our answers. Hopefully I did not. I kind of, oh my god, dude. Wait, I'm trolling. It's, oh my god. That is why you check your answers. We missed number 1. Let's go. Holy moly, dude. Essentially, I got it is 2 to 4 centimeters away from the top, which means it is, oh god. Yeah, what height above the sink? Small brain. Oh god. Okay. Pretend that didn't happen, okay? We got A, C, B, D. Okay. I like how we got the other 5, but we didn't get number 1. That's how it usually that's how it usually happens. I don't know why though. Oh well. Pretend that didn't happen. Okay. 2 cannons are arranged vertically with the lower cannon pointing upward and the upper cannon pointing downward, okay? 200 meters above the lower cannon. Simultaneously they both fire. The muzzle velocity of the lower cannon is 25. Okay. So, dang, why is this guy slower than the top guy? They're vertically, right? Okay. Huh, okay. So essentially you have like, the distance from the top guy is 55 plus 1/2 GT, or, yeah, wait, what? 55t plus 1/2 GT squared, right? And then the other guy, the upper guy, is actually going to do 25t minus 1/2 GT squared, right? So essentially, what, I guess this just cancels out, right? And then this is equal to 200 meters, and then you just solve for t, you get like 80? Yeah, so 200 over 80 What is that? Why am I so bad? 5 over 2, so 2.5. Okay, yeah. 6 is B. Easy. Okay. 7. How far beneath the top cannon do the projectiles collide? Okay, so that's just plugging in, right? Beneath the top. So we're not going to control and do height above the bottom this time. So what we got to do is you got to do 55 times 2.5 plus 1/2 times 10 times 2.5 squared. Okay. Time for some epic math skills, boys. 55, 25 times 11 is 275 over 2 plus 1/2 times 250 over 8, right? So that is the same thing as 125 over 4. That's not an integer, is it? I mean, does it have to be an integer? Okay, maybe, yeah. It's probably just round. Okay, we can just use a calculator. Why am I trying to do this by hand? Oh god. Plus 125 over 4 is 169. 170? Is that? Yeah, okay, that seems about right. What? Yeah, okay, that makes a lot more sense because this guy's like so much faster, right? And he also is going downward, so that would probably make sense. E is my answer. Let's just make sure we're not trolling. So it's 55 times 2.5 plus 1/2 times 10. Nope. 1/2 times 10 times 2.5 squared. Yeah. And we could just make sure by doing 25 times 2.5 minus 1/2 times 10 times 2.5 squared. And yeah, that's right. Okay. So we get 7 is E. A block of mass 3 kg, okay, is moving on a horizontal surface towards a massive spring. Okay, so which way are we going to do it? Okay, let's do left. So it's moving left, okay, 3 kilograms. And it has 80 newtons per meter. All right, that's kind of hot. No, I'm kidding. That the coefficient of the kinetic friction between the block and the surface is that, and the speed it has. Okay, so essentially with these questions, you basically want to do conservation of energy. So you just do 1/2 times 3 times 2 squared, right? That's kinetic energy. Then you want the spring kinetic, or no, spring potential energy once it's compressed. And you want the work done by friction, right? Which is just x times the frictional force, which is mg mu k, right? So you have mg mu k, yeah. So we'll just plug in everything here. I mean, oh god, it's a quadratic. I hate quadratic so much. Okay, it's fine. So we basically get, maybe it's a nice quadratic. So you get like 6 equals 40x squared, and then mg. So 3 times 10 over 2 is 15, right? Yeah, 15x. Okay, yeah, this is not too bad, right? So if we could factor it, that would be kind of epic. So you get like 240, right? You want to get that a sum to 15. So what factor of 240 sum to 15? Is it like, you need 1 to have all the evens. So you have 8 times, no, 16 times 15, no, what? Oh god. 16 times 15, technically, right? But we would have probably had a 48, no, what? How do you factor this? Okay, you know what? Let's do quadratic formula. Quadratic formula to save the day. So, negative 15, I just hate using quadratic formula though, it's fine. Plus square root of 15 squared minus 4 times 40 times 6, I guess a negative 6, so this is a plus. Alright. And then you divide this whole thing by 2 times, divide by 80. What? Seriously? No, wait, what? Okay, I guess it is divide by 80. 0.24. Oops, don't want to look at that. 0.24 is B. Alright. 8B. 9. A uniform spherical planet. I love gravity. Well, I guess I have to because it's what keeps me on the planet, okay? But not when it comes to FMA. A uniform spherical planet has radius r and the acceleration due to gravity at a surface of g. What is the escape velocity? Okay. So, essentially what acceleration due to gravity is saying is that gm over r squared is equal to g, right? So essentially you want escape velocity from the surface, right? So your potential energy, you want your kinetic energy to equal your potential energy, right? So essentially your potential energy is negative gm over r, right? Gmm over r. And that is equal to 1/2 mv squared. So if you just solve for this, this is like this is like GR, right? GR or MGR, negative MGR. Is that right? Yeah. And then essentially, oh, I guess it's like literally just root 2GR. What is the negative? Oh, I guess yeah. Oh, yeah, it's like this is plus this is equal to 0, so that's why. Okay, so this is just root 2GR, so 9 is C. Unless I'm memeing, but I'm pretty sure I'm not memeing on this one. Hopefully not. I still can't get over how I missed number 1. That was so sad. Oh, God. I know I said we were going to pretend that it didn't happen, but that was just sad. Okay, 4 objects are placed at rest at the top of an inclined plane and allowed to roll without slipping to the bottom in absence of rolling resistance and air resistance, okay? Object A is a solid brass ball, alright. Solid diameter D, so that's like, okay, so solid is, the way I remember it is like solid has more stuff closer to the center, so it should have a smaller moment of inertia, so 2/5 mr squared. Do they have the same mass? Okay, well, for sure, like, when you put rolling things on an incline, the only thing that matters is it's like, I over mr squared, right? So essentially your mr squared doesn't actually matter, but what matters is your coefficient here, right? So, so essentially the solid brass balls should be the same, um, right? Yeah, solid brass balls should be the same. Hollow brass guys should be. That's like how fast, right? So the bigger, the bigger your the bigger your coefficient, the slower you're gonna go. So your object C is gonna be the slowest. Density, does density matter? Pretty sure it doesn't. So TC should be greater. So it should be D. All right. We got our answers over here. We got B, E, B, C, D. Okay, we didn't miss anything. From 6 to 10, let's go. Alright, next 5. As shown below, Lily is using the rope through a fixed pulley to move a box with constant speed v. The kinetic friction coefficient between the box and the ground is mu is less than 1, alright? Assume that the fixed pulley is massless and that there is no friction between the rope and the fixed pulley. Then, while the box is moving, which of the following statements is correct? Okay. The magnitude of force on the rope is constant? No, right? Because essentially, is it? Okay, maybe it is. Okay, hold up. So we essentially have this. We have some constant friction that way, right? So that's just going to always be mg mu, right? And then the upward force is angle like theta, all right? And then you got like force, well, this is like mg minus f sine theta mu, right? And then this force has to be equal to that, right? So f cosine theta is equal to the frictional force. So, I mean, this basically suggests that it's not constant, right? Because when theta changes, your force does have to change, okay? Magnitude of friction between the box and the ground. Yeah, that should be right? Because essentially you're getting more upward force, so I'm pretty sure that, is the force constant though? No, but the force is not constant. Okay, this is triggering. Okay, so let's just solve for the force first. So you get f times cosine theta plus sine theta mu is equal to mg mu. Wow, okay, so essentially your magnitude of friction is going to be, what? Yeah, your force of friction is going to be like mg minus mg mu over cosine theta plus sine theta mu, right? Oh god, that is disgusting. What? Okay, let's see if there's another thing. Magnitude of the normal force of the box, ground on the box. Okay, the part I don't really get is like your force. Bruh, why can't I see my cursor anymore? Oh, right, I don't know. Oh, my think it's probably too small. No, I have no idea. Okay. So, what? Okay. Let me think properly. So the magnitude of the force on the rope is constant. I'm pretty sure that's not true because like you have this change based on the angle, so probably not. Um, the magnitude of friction between the box and the ground is decreasing. Okay, so is this increasing or not? um, so cosine theta is increasing, sine theta is decreasing. Or no, sine theta is increasing. So your oh my god, this is triggering. Um, okay, well I guess we could just logic it out, right? So it's probably not constant, right? So E is probably not right. Um, so it's either B or C, but C and D are the same, so it should be B. Very good logic. Bro, why can't I actually see my cursor? This is triggering. Ah. Okay. 11 is C. No, B. B is what we got. Alright. What do we got now? A rigid hoop can rotate about the center. Two massless strings are attached to the hoop, one at A, the other at B. These strings are tied together at the center of the hoop at O, and a weight is suspended from that point. The strings have a fixed length regardless of tension, and the weight G is supported only by the strings. Okay. Originally, OA is horizontal. Okay. So now they move slowly 90 degrees so that OA is vertical and while keeping the tensions. Okay. So essentially, if your T1 is going upward, right? Like right now, T1 only has to oppose the T2 going right? But T2 is basically supporting the entire weight of the object. So, in that case, bruh, this is actually so annoying. I'm not even sure what the problem is. You know what? We'll figure it out. Oh, I could just hold this for now. Okay, that works. So basically, when you're rotating it, some of the upward force is actually getting put on T1. But, okay, well, let's see. Well, yeah, okay. I don't think we even had to think about it too much. So, basically, OA will become vertical, right? Which basically means that OA is supporting all of the vertical force from G, right? And then essentially that means that if you added any force on T, like if T2 is greater than 0, it would basically move the box to the right, which you don't want. So essentially D should just be correct. So 12 is D. So it has to be 0, otherwise it would be moving. Okay. 13. Shown below is a graph of the x component of a force versus position for a 4 kilogram cart. Okay. At x equals 0, the cart has a velocity of negative 3 meters per second in the negative direction. Wait, what? Okay, well, yeah, okay. It was negative 3 the negative direction. Would it be positive? No, I'm pretty sure. Okay, so that's probably just negative. Okay. Which of the following is close to the maximum speed of the cart? So originally the force is telling it to go the opposite way. So either the maximum speed is here, right? Or the maximum speed. Oh, this is per at meters. Okay. So wait, what? Okay, so it starts moving this way, right? So it's always slowing down. Then it goes this way, right? It speeds up, and then it starts slowing down. So, and the area is basically like how much it slows down, kind of. Well, it's like how much work is done on it. And basically the work is kinetic energy, right? So essentially this area over here basically does not cancel out this area. So either the max speed is here or the max speed is negative 3, but I'm pretty sure it won't be negative 3. So essentially we get to like positive 3 on the way back, right? That's just because it has a constant acceleration. And then once we have 1/2, bruh, so we got 1/2 times 4 times 3 squared. Then we want to add the amount of work done from x equals 0 to x equals 6. So that's just the area under the curve, which is 1 times 6, no, 1 times 5. Oh my god, this is so annoying. I don't even know what did I do. Alt, window. Nope. God dang it, dude. Okay, control is what we're using. So 5 plus the area of the triangle, which is 5 times 5 over 2. And that should equal our final kinetic energy is equal to 1/2 m or times 4 v squared. Okay. So now we just gotta solve this. Okay, so the right side would be 35 over 2, right? Or yeah, so 1/2, bro. You guys gotta see me troll around. Okay, 1/2 times, bro. 1/2 times, bro. I'm so God dang it. Okay, there we go. There we go. 1/2 times 36. There we go. 36 plus 35 is equal to 1/2 times 4 v squared. So essentially v squared is equal to 71, which is kind of troll. But let's see what. No, what that's not right. Oh, 71 over 4. So root of 71 over 4 is 4.2, which is E. Let's go. Oh, I should probably erase the rest of this stuff. Okay, so we got 11b, 12d. 11b, 12d. 11b, 11, bruh. Oh, what's going on? Okay, so now, alright, you know what? This is actually so triggering. Okay, so we got, jeez, okay, you know what? Pretend that that's in the center of the screen. 11b, 12d, and 13e. Okay. Ah, technical difficulty. This is actually sad. Okay, 14. Oh, these ones are kind of fun. So essentially, you got radius A and has a weight of 80. Okay, and you drill out of it. So essentially, the fun way to do this is to treat that extra cylinder that you took out as a thing with negative mass, right? So, or negative moment of inertia, kind of. Well, what's it asking for? Okay, force T is. Oh. Okay, so essentially, like, basically, oh, why is my cursor back all of a sudden? Okay, there we go. I'll take it. Thank you. All right. There. So, essentially, what this is saying is that you got like this, you got like this, and basically this is like, you can kind of think of it as an upward force, right? So, it's like an upward force of the mass, and then essentially you want to counteract that torque about this point, right? So, this one exerts, what is the, okay, so this thing weighs 15 newtons, right? And then this is 2a, right? 2a over 5. So essentially we got 15 times 2a over 5, which is 6a, is equal to the torque this way. So we need the torque this way to be the same. So this is over here, 2a. So we need equals 2a. So this has to be 3 newtons. Okay. And that's not right. Hold up. So 15 newtons, right? 65, yeah. So 15 newtons upward. And then 2a over 5 here. Yeah, that's right. And that gives you 6a, alright. And then 2a times that. Or is it from here? What? Let's think. Um, I keep forgetting. Do you do it from the center or do you do it from here? But I'm pretty sure this is a pivot point, right? So that's what we should try to balance. Unless I'm trolling. Okay, like the answer is probably A, but I want to just make sure I know why. Let's see. I mean, I guess. Yeah, okay, I guess it is from here, so this would be A, then this would have to be 6 newtons in order for this torque that's going this way to cancel out, right? Alright, makes sense, I suppose. So, answer is A, 14A, alright? Now, a car of mass m has an engine that provides a constant power output of P, assuming no friction. What is the maximum constant speed Vmax that it could drive up a long incline? Okay. So, essentially, like, your power is equal to force times Vmax, right? So now we just need to find out what our force is, right? That's going opposite. So that's just gravity. I'm assuming there's no friction. So yeah, it says assume no friction. So our force is just mg cosine theta. All right, that right? Yeah. Is it? Okay, so you got like this theta. No, sine theta. I'm trolling. Mg sine theta. Mg sine theta Vmax is equal to power, and you want to find the maximum constant speed. So shouldn't just be A, unless I'm trolling. Pretty sure it should just be A. So our answer is A. Alright, I think 30 minutes is almost up, is it? Oh shoot. Okay, hopefully you guys don't have to listen to that on your on your in the recording, but I did not notice. But well, let us check our answer. We got A for 15, and we will see how much we got right. Okay. We got 11 is correct. Okay. 12 is D. All right. Wait, what? Yeah. Okay, that's right. E, A, and A. Very nice. Okay, we got all of that right. So far, we got 14 out of 15 with only number one miss. I'm pretty proud of that. God dang, why did I have to miss one, dude? That would have been so epic. But anyway, that's all I got for you guys today. Remember, if you guys have suggestions for next time, make sure to leave them in the comments. Remember to like and subscribe, all that good stuff. If you guys want anything else on the series, I literally am free to do anything that you guys want. I'm just trying to get 30 minutes of problem solving down, okay? Whatever you guys want, just let me know. But other than that, thank you guys for watching again, and see you guys next time. Alright. Bye-bye, get out of here.